To Aristotle, this ball swinging around a string is in uniform circular motion. You can see it's moving at a constant speed around a simple circular path. Aristotle would have claimed that this object is not being accelerated at all because its speed isn't changing. It's neither speeding up nor slowing down. But Newton had a completely different view. Newton said that an object only changes its direction or its speed in the presence of a force. Well, the speed is constant, but the direction is constantly changing around and around as we go. Once up, once down, once left, once right, and all the way around the circle. Newton says this object is accelerating. And manifestly from the experiment it is, because I can feel the force I have to be putting through the string, keeping it swinging around. As soon as I let that force off, it just basically falls back down and stops moving. Newton's key insight was the understanding that acceleration is not just speeding up and slowing down, our everyday notion of accelerations, but also a change of direction of that motion at a constant speed. The second law tells us that this must be so, and I can understand completely and predict the motion of the ball swinging around the string just by using force equals mass times acceleration. I can even change the direction of the swing so that I'm swinging it over my head. As I move it around, if I want it to go faster, I have to put in more force, but when I regularize that force, it swings around at a constant speed, but the direction is continually changing due to that acceleration. Now, what would happen if the string were to break or I were to release the ball? That's when Newton's first law comes into play. In the absence of forces, the natural tendency of an object is to move in a straight line at a constant speed. And there it goes. It doesn't follow the arcing path that was impressed upon it by my accelerated motion. It flies off in a straight line at the position it was moving at the time that I let go of the string.